Good day, guys. What's up, YouTube? We are from N4AM, students of Sir Adrian Parillo, and we are going to report what counting sort is, no? Anyway, moving on with its algorithm description. So, counting sort is a simple algorithm used for sorting numbers, no? It doesn't compare values like bubble sort or quick sort. Instead, it counts how many times each number appears in the list. Once it knows how many of each number there are, it uses that information to arrange the elements in order. Guys, this basically means that counting sort is a non-comparison based sorting algorithm. It doesn't sort elements by comparing them directly, like bubble sort as mentioned, no? Instead, it works by counting how many times each value appears in the input list. Also, counting sort work best when the numbers are small or within a known range. For example, if we are sorting grades from 0 to 100, counting sort is very efficient because the range is limited. Now, let's go with its algorithms, its step-by-step process of how it works. Step 1, we have the find the largest number. In step 2, count how many times each number appears. Step 3, add up the counts, cumulative counts, and lastly, step 4, place each element in its correct position. Anyway, explain this further. No, in step 1, before we start counting, we find the largest value in the list. This tells us how big our counting array should be. No, it needs to fit all possible numbers up to the largest one. Meanwhile, in step 2, um, count how many times each number appears. We create a count array to keep track of how many times each number appears in the list. We go through each element and it increases the count of the index. And step 3, we add up the counts, cumulative counts. When we say cumulative counts, let's say that you think of each number as a floor in a building, no? The count array tells how many people live on each floor. The cumulative count tells how many people live from the ground up to that floor. So knowing the cumulative total, you can tell how high you've climbed in the building in or in sorting term, how far along the list that number group should end. And finally, in step 4, we place each element in its correct position. And that's all for my part. Let's move on with the visualization of its algorithm that will be presented after this.
So to visualize the algorithm of counting sort, first consider the following sample array. So here we have an array of size 7 with the values 4, 2, 2, 8, 3, 3, and 1. So based on the description of the algorithm, the first step is to find the largest number in the array, which is 8 in this case. Then we make a count array of size 9, which is 8 plus 1, and then proceed with step 2, which is to count how many times each number appears. So here we have the sample input array, we have the count array where all the values are initialized to 0, and the count of appearances, which is the end result of the iteration of count of the appearances inside the input array. So in iteration 1, we look at the value inside the first element of the sample array and add 1 to the index that is equivalent to the value of the first array. So here we have 4, and then going to the count array, we iterate until we reach the value that is equivalent to the until we reach the index that is equivalent to the value of the first index of the sample array. So we have at index 4 we add 1, and here at iteration 2, So we have 2 as the value, as the next value, and then going to the count array, we add 1 to the index that is equivalent to the current element in the sample array, and this process is repeated until we reach the end of the input array. The next step is to add up the counts, or the cumulative count. So the formula for this would be count I is equal to count I plus count I minus 1. So in the first iteration, we have count 1 is equal to count 1 plus count 1 minus 1, which is 0. So here we have count 1 is equal to 1 plus 0 is equal to 1. And we replace the value we get here inside the count array. So at index 1 of count array, we add 1. We replace it with 1. In iteration 2, so we have here count 2 is equal to count 2 plus count 2 minus 1, which is count 1. And then we add the values inside these indices, which is 2 plus 1 is equal to 3. And as you can observe, we are in count index 2 is equivalent to 3. So we replace the value from the previous we replace the previous value with 3, which was previously 2 in the first iteration, and this process repeats itself until we reach the last index of the count array. So the final step would be to place each element in its correct position. Okay, so we have here the first array, which is the input array, the cumulative array, which we got from iterating through the count array by getting the cumulative count. So here's the result, which is equal to this one. And then we have the output array, which will be what would be displayed in the output if this was coded. So take note, it is initially empty, or basically these are initialized to zeros. Also, one more note would be the fourth step. The iteration will start from the end of the input array up until the beginning. So here in iteration 1, we have j is equal to 6, because 6 is the last index of the input array that we have. So 0, 1, 2, 3, 4, 5, 6. There. Next, we get the value inside the input array of the current index. So at input index 6, we have 1, which is 1. And then to get the position, using the value from input 6, we apply it to the cumulative count array minus 1, which is 1 minus 1 is equal to 0. So position 0. So the first input would be at position 0. As we can see from here, output index 0 is equal to 1. And this process repeats itself until we exhaust the entire input array, getting this final output here: 1, 2, 2, 3, 3, 4, 8.
So now, let's talk about the efficiency of counting sort algorithm. The time complexity of counting sort is O of n. This means the running time grows linearly with the number of elements we're sorting. Why is that? Because counting sort doesn't compare elements like bubble sort or quick sort. Instead, it just goes through the list a few times. So first, it counts how many times a number appears. This scans the list once, so that's the O of n. And second, it computes the cumulative counts. It loops through the count array once, and again, it's O of n. Lastly, it places each element in its correct position in the output. Another pass through the list, so it's still O of n. So counting sort is very fast when the numbers are small or the range of values is limited. However, it's not efficient if the range of the number is very large, because the count array will also be large and take memory.
So here is a sample pseudocode for the counting sort algorithm, and let's go through it statement by statement. In statement 1, find the element with the highest value k in array A. In statement 2, we create a separate array C with its size being k and set all its elements as 0. In statement 3, for each element x in array A, we set that element x as an index in array C and add 1, so that we can count how many instances of that element are in array A, in a sample code from below. In statement 4, for I starting at 1 until the maximum value k, we have to add the value of each element in array C to the previous element, and a code to represent that below. In statement 5, we create an array B with the same size as array A to store the soon-to-be sorted elements. In statement 6, we iterate through array B in reverse order with j as a starting point until we reach 1. So in the first line of code, we transfer the elements of array A to array B by setting the index of array B as the value of the element in array C minus 1 with the index of the element value in array A. Then we decrease the value in array C by 1. In statement 7, we print out the sorted array in array B. And for a more simplified explanation, here it is. We first count how many times each number appears. Then we calculate where each number should be placed in the sorted list. Finally, we put each element in its correct spots in the output array.
Hello, now I will be discussing about the code of count sort. Here we have an array which holds values that we will be sorting, and we have an integer n which will represent the size of this array. Now we will go to the count sort function. As you can see, we have parameters which is the array and the size of the array. Here we have declared another variable k which holds the max element of the array, and in count which will hold the frequency of each element inside the array. Here as you can see, we are getting the frequency of each element and then putting it into count. Here we can see count index is equals to count index plus count index minus 1. So this basically gets a cumulative sum, and this cumulative sum will now be representing the position of the elements that we will be putting inside another array here. As you can see, the array and its index, just the count is 1. Then the value that we will be putting here is the value from the original array here. And here, as you can see, we are now passing the sorted array into array I. Now here we will be displaying the sorted array.
And that's all for our presentation. Thank you guys for watching.